So now we're ready to talk about complex numbers and what they are and how you add and subtract them, how would you graph a complex number, and how to evaluate the absolute value of a complex number. Okay, so what is a complex number? Complex number is a number that has a real part added to an imaginary part. So a plus bi is considered a complex number. And a and b, those values are going to be real numbers, and of course I is defined as the square root of -1. This is called the standard form of a complex number, where the real number a comes first, and then the imaginary number, the pure imaginary number, bi, comes second. So for example, 5 plus 2i, that's a complex number. -8 plus -√2i, that is technically a complex number in standard form. However, typically we don't write it like that. We would write it more like this, where plus the negative, who cares about that? We can just simplify that as minus. And I personally like to have the I in front of any radicals because, as we know, some people have messy handwriting, and if you extend the radical sign and put the I and it looks like it's under it, then we don't quite know where that I is supposed to belong. So I would appreciate having the I in front of any radicals that you might have. Otherwise, it would go second. Okay, so when you add and subtract complex numbers, it's just like combining like terms, like we saw before. I know this is very general with A, B, C, and D, but if you think about it, A and C here of these two complex numbers are the real parts. You're going to add them together. And then the BI and the DI, those are the imaginary parts. You add them together, and this is what you would get. So in an easier format, an example, 2 plus 3i, and add it to 4 minus 5i. You add the 2 and the 4 together, you add the 3i and the -5i together, and you get 6 minus 2i. It's really that simple. All right, so when you subtract, you just have to remember to distribute your negative sign. Either rewrite it with the negative sign, distribute it through, or just remember about it when you are combining like terms. So 8 minus 3, that's going to give you the 5. -5i minus 6i, that's going to be a -11i. Okay, so let's take a look at our, like Venn diagram of numbers, number sets. So we should all be very familiar with this circle over here, the real numbers, which are broken up into rational or irrational, and then the rational are broken up further by integers, whole, and natural numbers. But where do the imaginary and complex numbers fit within that? Well, they actually are not within this circle of real numbers at all, because your number is either going to be real or imaginary. So imaginary numbers have their own separate set over here that doesn't overlap. And so there's our numbers that are considered pure, like 4i, 24i, -5i, all of those. But when we want to combine a real number and an imaginary number, that becomes a complex number. So everything really fits into the set of complex numbers. And you might be wondering, well, 5, that's not a complex number. That should be over here in like the natural, whole, integer, rational, all of those. But you could consider it a complex number, and it's just a complex number where b is 0. So, got to think of it in the grand scheme of things there. All right, so let's take a look at how you would graph a complex number. So complex number a plus bi, you are going to graph it on a different plane. We can't graph it on the Cartesian coordinate plane anymore because the Cartesian coordinate plane doesn't have imaginary numbers in it. Those are only real. So we created the complex plane, which is made up of a real axis and an imaginary axis. And when you graph a point on it, it's like working with the Cartesian coordinate plane, where you have a point A and B, kind of like the X and Y. But the A, B, those are coming from the real and imaginary parts of your complex number. So the real axis is going to be the horizontal one, and the imaginary axis is the vertical one. So let's give it a go. Z equals 3 plus 4i. If we're going to graph that in the complex plane, take out the 3 and the 4, you're going to write that as the point like AB, so 3, 4. And so all you're going to do is, we'll take this big dot here. So 3 is the real part, 1, 2, 3, and imaginary part is 4, 1, 2, 3, 4, and there it is. Okay, so that's it. That's how you would graph a point. Pretty easy. Okay. So what is the absolute value of a complex number? Well, technically it is the distance from the origin to the complex number in the complex plane. So what does that mean? Well, here's a diagram. How lovely. All right, so if this is the complex plane, here's our number, z, absolute value of z, which would have the point a being the real, b being the imaginary. And when we talk about the absolute value of our complex number, we're looking at this distance from 0 out to that point. So how do you think we could figure out what that distance is, knowing that this length is a and this length is b? Well, you can either use Pythagorean theorem or you could use the distance formula. So it ends up being the square root of a squared plus b squared, which is great. So that means that the absolute value of z, which is the absolute value of a plus bi, is the same as the square root of a squared plus b squared. Very simple calculation you all should be able to do. So let's try it out. Find the absolute value of -5 plus 12i. So there's a, there's b, plug it in, and we end up getting 13. So the absolute value of this is 13. So why is this useful? Well, we use the absolute value of a complex number in order to compare them to one another. So which one's bigger? When it's in this form, you can't really tell. So you go through and you figure out what the absolute value is of each of them. So the first one is going to be 5. Second one is 5.1 or something thereabouts. But really, if you just look at the square root of 25 and the square root of 26, we can see which one is bigger. We didn't even need a calculator to figure that out. So that means that 1 minus 5i is larger than the 3 plus 4i. So I ask you this question. What does the comparison of the absolute values tell you about the points in the complex plane that represents them? I'm not going to answer that for you. I just want you to think about that. Okay, we're done.